Hey everybody, this is Mike for Faraday Research, and just doing a little test with the pulse motor tonight. I had a couple of ideas I was working on, so I got it working right now. And what I have done, as you could tell, you can probably see the flicker, but not very much. It's very blended within the camera. I don't know if you can really notice it that much. But what I've done is the power line. What I've done is I added a capacitor in there. Now it's showing my high volt spikes hitting around 51 volts. But what I did was, because I'm not guaranteed what my hertz, the pulses coming off the pulse motor itself, what I've done is I've bypassed the power that's coming from the pulse motor and going through a MOSFET chip and hooked it up to my 555 timer. So right now I got it set at 60 hertz and a 60% duty cycle. Now what's really cool about this, I can actually control the frequency that's going into the light. So I'm gonna bump it down, see if you can notice it. I'm gonna try bumping it down here. I'm gonna bump it down to... Okay, so I got it at 60 hertz, and I got it at a 20% duty cycle. So now you can see the difference in the frequency waveform that's going into the light. So, I actually also tried that trick of where people like to short out the capacitors, and then you get that burst of power. Yeah, it works great, but I tried it with the 555 timer circuit, and I did it at really high hertz, like in the kilohertz, and I tried it really low, and I wasn't getting the results I wanted from it. Still trying to figure that out. But if I can do that, accomplish that, number one, my high voltage output will be way, way, way higher. And number two, a lot of people, they'll short out the power and use that high voltage spikes to fill up capacitors. So what I wanted to do is actually hook that up to a 555 timer circuit and actually shorting it out using the 555 timer. So food for thought. I didn't get the results I really wanted from it. I'll have to tinker with that, but I might be onto something. Who knows? But definitely I like this because now I can control the actual waveform that's coming out and going to the light. So now I have full control. Even though that I have a certain frequency I'm working with the pulse motor, that means now I could run it lower. Right now, I'm only using 12 volts at 130 microamps, so I could even go lower than that. I've actually run it quite a bit lower. Let's see, I go down to 12, even 11. There I am at 10, and that's 120 microamps, 120 milliamps, excuse me. And now you can see that the frequency has changed. So in that case, if I were wanting to speed it up, now I adjust my frequency. Now I can bump up my frequency now faster. So I'm gonna bump it up from 60 hertz to 100 hertz. And the duty cycle, let's try going a little bit higher. I can go up to 130. So as a result, now that I'm using less power going into the system, I'm still maintaining almost 50 volts coming out on the high voltage spikes. So food for thought. I might be onto something here. Timing and frequency seems to be the key with these motors and pulse generators. So I know I'm getting 50 volts. I'm only putting in 10.9 volts at 120 milliamps, which is nothing. And I'm still able to maintain the light and also control the frequency. So right now it's at 100 hertz. And let's bump it up, say, we're gonna go even higher. I'm gonna really crank it up. Let's get it up to 1 kilohertz. See what happens. 700. Okay, I'm at 1.36 kilohertz, and I'm gonna drop the duty cycle down lower at 15%. So yeah, I'm still really maintaining a pretty high power output, plus my high volt spikes are still at 48, 49 volts, and power going into the system is 10.9 volts at 120 milliamps, 110, 120. So I'm not really not really putting that much in, and I'm getting some good power. The wheel kind of slowing down, I noticed. That's obviously because of the amount of power I'm putting into it. So we're going to crank it up one more time. Let's put it up to 13. Okay. Now you can see the light. And we're running at 1.36 kilohertz at a 14% duty cycle. That's what I'm firing this light off at. And my voltage obviously went up. It's 48, 50 volts, 51 volts, high volt spikes. Now that the pulse motor is actually running a little higher RPM. I don't really trust this meter here. It's not very accurate. So I wouldn't really go by that one. But you can see it running. And also too, I'm going with the spark gap switch. I swear by it. Tesla swears by it. And I'm going with what he says. So mechanical spark gap, it's also a switch. And yeah, I'm always going to be using a spark gap switch. I don't care what anybody tells me. That's the only way you're getting in the radiant energy. I did a lot of reading on this. I dug up a couple of videos that talks about what Tesla was doing with the spark gap. And you cannot extract radiant energy from the atmosphere better than a spark gap. So I'm staying with the spark gap. I'm going by my instincts on this one. You know, a lot of people might fight me on that one, but you know what? I'm going with my sheer gut instinct on this one, and I seem to be getting the results I like. So I'm getting like 50 volts, continuous 50 volt, high volt spikes. So I'm flickering the light at a very high hertz level, which is making the light run quite well. So 1.36 kilohertz and 14% duty cycle. So she's firing pretty fast. So even though that your RPM and your hertz frequency off the pulse motor might be insufficient, you can get that back later if you use a 555 timer circuit with a MOSFET. I'm using the MOSFET for that. I'm still got my spark gap switch there, which will always be there. I'll never switch that. You can get higher frequency, obviously, with a MOSFET. Well, you can with a spark gap if you get it set up properly, but you also have to run it at a very high hertz level. And that's what my Don Smith generator is going to be working with. I'm going to be using a traditional spark gap. So anyways, yeah, here's some little testing I've been doing. The light is running really fast now, so I don't know if you can really tell on the camera how well it's running, but yeah, it's running at a very high frequency. And the MOSFET chip is cold. There's no heat generated whatsoever. And it's putting out 50 volts, no problem. Consistent 50 volts. So yeah, leave your comments at the bottom. If you like the video, give me a thumbs up. And in the bottom right-hand corner, if you haven't subscribed, subscribe to my channel. Yeah, this is my pulse motor, and we'll see everybody in the next video. I'm starting the construction of the Don Smith generator. I'm kind of torn on the design of the inductor antenna that I'm going to be using for it, so I'm still fighting myself in my head about that one, because there's a couple good designs I want to do. Maybe I'll just do both of them and try both of them out. So anyways, any comments, leave it at the bottom, and we'll see everybody very soon.